Dear friends, good morning. Today we are going to discuss about gear trains. Myself, Kadirvel, Assistant Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology, Coimbatore. Is defined as a combination of gears that is used for transmitting motion from one shaft to another. Gear train is necessary when it is required either to step up or step down the speed of the driven shaft. However, the most applications use gear trains to obtain large speed reduction within a small space. A gear train is two or more gear working together by meshing their teeth and turning each other in a system to generate power and speed. The gear trains can reduce the speed and can increase the torque. The electric motor are used with the gear system to reduce the speed and increase the torque. The speed ratio is the term which is very important to design this gear train with specific speed variations. The speed ratio may be defined as the ratio of speed of the driving gear to the speed of the driven gear. Based on this speed ratio, the gear value or the train value will be designed. So that is nothing but the reciprocal of this speed ratio, that is called the train value, that is nothing but the ratio of the speed of the driven gear to the speed of the driving gear. The types of gears. So the gear trains can be classified into two types. One is ordinary gear trains, another one is epicyclic gear trains. So these two gear trains are further classified into simple gear trains and compound gear trains. And the compound gear trains are further classified into two types. One is a riveted gear train, another one is non-riveted gear trains. In a simple gear train, when there is only one gear on each shaft, it is known as a simple gear train. The most common of gear train is the gear pair connecting parallel shafts. The teeth of this type can be spur, helical or herringbone. It can be seen that the motion of the driven gear is opposite to the motion of the driving gear. The train value of this simple gear train can be given by the speed of the driving wheel to the speed of the driven wheel, that is equal to the ratio of the diameter of the driven shaft to the diameter of driving shaft. That intermediate gears or the ideal gears can be used for the change the direction of the driving wheels. That will be shown in the figure. So this figure clearly shows that the first wheel rotates in the direction of counterclockwise, and the second mating gear in the same gear train rotates in a clockwise direction, and the third gear rotates in this anti-clockwise direction, and the fourth gear rotates in clockwise direction. So that in the simple gear train, the pair of gears are in mesh or rotates in this opposite to the each other. So this is called simple gear trains. Next one, planetary gear trains. The planetary gear train is also called as epicyclic gear train. When the axis of rotation of one or more gears is allowed to rotate about the another axis, then the gear train is known as epicyclic gear train. Epi means upon and cyclic means around. Thus, in epicyclic gear train, one or more gears move upon and around another gear. The difference between this epicyclic and the other gear trains, in case of simple compound and riveted gear trains, the axis on which the gears are mounted are fixed relative to each other. But in epicyclic gear trains, the axis of the shafts on which the gears are mounted may have the relative motion between them. The advantage of epicyclic gear trains over simple or compound gear trains is that it can achieve high speed reductions within a very limited space. Applications of this epicyclic gear trains find many applications, that is in automobile differentials, machine tools, hoists, pulley blocks, wristwatches, aircraft propeller reduction drives, automatic transmissions, etc. The epicyclic gear trains can be subdivided into two classes. One is simple epicyclic gear trains, another one is compound epicyclic gear trains. This planetary gear trains, when there is only one gear on each shaft in any epicyclic gear trains, then they are called as simple epicyclic gear train or simple planetary gear trains. So the main elements of the epicyclic gear trains are, one is sun gear, another one is planet gear, another one is arm or the ring gear. The epicyclic gear trains are also called as planetary gear trains or sun and planet gear trains because of the fact that the gear rotates around in another gear just like a planet moving around the sun. And next one, compound gear train. When there are more than one gears on a shaft in an epicyclic gear train, then they are called as compound gear trains. The epicyclic gear train has three planet gears, the arm and the armless gear. The armless gear is nothing but the internal gear, that is a sun gear. The sun gear is free to revolve, whereas the armless is fixed, that is a ring gear. And planetary pinions, three gears, are rotated around or inside of the ring gears. So this is called compound epicyclic gear trains because one shaft carries more than one gear and which is rotates and revolves around the another axis. So that is called compound epicyclic gear train. The planetary gear trains have higher gear ratios. They are popular for automatic transmissions in automobiles, and they are also used in bicycles for controlling power of pedaling automatically or manually, and they are also used for powertrain between internal combustion engine and an electric motor. When two gears are fixed on the same shaft, then the gear form a compound gears. A gear train having one or more compound gears is known as compound gear train. The low speed electric motors are available in the market. The high speed motors are commonly used because they are comparatively smaller in size and cheaper in cost. The advantage of gear train, that is a compound gear train over simple gear train, is that it can provide higher speed reductions for the given center distance between the input and output shafts using smaller gears. With use of this compound gear train, the shaft, that is a driving shaft, can be rotates in the same direction. We can achieve the same direction of rotation in the driving shaft also with the help of this compound gear trains by using a minimum number of gear wheels. There are many applications that requires lower output shafts. Generally, these applications are run by high-speed electric motors. In such applications, the compound gear trains are used to achieve the required larger speed reductions. A compound gear is a number of gears fixed together. Consequently, they rotate at the same speed. The gears that makes up a compound gear usually differ in size and have a different number of teeth. This is useful if there is a need to speed up or slow down the final output. Sometimes a simple gear train cannot provide a big enough gear ratio. If a large reduction in speed or increase is required, then more than one set of gears can be used together. This is referred to as compound gear trains. With this compound gear train, we can achieve a large velocities. Compound arrangement is preferred. Two or more gears may rotate about a single axis. Just watch the rotation of the gear wheels A, B, C and D. In this gear train, gear B and C are fixed on the same shaft, rotates in the same direction, but at the same speed. Okay, so by this way we can achieve the different or the higher speed reductions or the step ups with the help of this gear trains. In this example, the gear train below has an arrangement of two wheels including two compound gears. The gear train like this are often found inside the machines such as central lathes and milling machines. On a smaller scale, plastic gear trains are found inside the DVD recorders. They are ensured that the DVD disc spins at exactly at the right speed. The compound gear trains uses a compound gear consisting of two or more gears of different sizes that are mounted together on the same shaft, as shown in the below figure. Each gear of the compound gear forms a simple gear train with its adjustment meshing gear. When we comparing this compound gear system with the simple gear system, we have some advantages as well as disadvantages. The main advantages of the gear train transmission system is that because the teeth on any gear intermesh with the next gear in the gear train, the gears cannot slip. An exact ratio is maintained. Large forces can be transmitted. The number of turns a gear makes can be easily controlled. High ratios between the input and the output are easily possible. This is the main or the important advantage of the compound gear system. And the main disadvantage of gear system is usually needs a lubrication system to reduce wear to the teeth. Oil or greases is to be used to reduce the friction and the heat caused by the teeth rubbing together. So this is the main disadvantage of the compound gear system. So finally we can conclude these are some important gear trains used for various purposes or various engineering applications. And most common the epicyclic gear trains used in different places where the sun and planet arrangement is needed. The finding of suitable gear train is a challenging task to the design engineers to to design a perfect gear train for the suitable applications with low cost. And finding of gear materials and gear manufacturing process, etc. The design engineer should be focused on these titles also, aspects also, and they can find a suitable gear trains and number of gear wheels, number of teeth, size, weight of the gear train, etc., etc. These are to be keep in mind to design the gear trains. So with this kind of gear trains are very familiar and used in wide applications of engineering industries. Okay, so friends, I hope you all understand about this types of gear trains used in wide applications, and we can discuss with some other topic. Thank you.